Welcome. In this video, we're going to go through the answers for the C2 revision worksheet, beginning with the calculations for relative formula mass. Remember that if you're not sure of how you should do these, you can separate them out kind of into longhand. So you're doing 1 times the relative mass of nitrogen plus 3 times the relative mass of hydrogen. No, I think they use a different notation, don't they? So you're doing, 1 times the mass of nitrogen plus 3 times the mass of hydrogen. There aren't any in this set of problems, but if you ever see something wherein you've got brackets, just remember that the number outside the brackets applies to both parts of the brackets and make sure you include that. Calculating empirical formula, you're just finding the smallest ratio between them. So you find the largest common factor and then divide each of the numbers by that. You may also have to do it from recognizing elements in a diagram. So your first step is to write out the formula for that diagram using the key, or sometimes they will actually have them labeled. And then you find the empirical formula from that. Remembering that pure substances are only one element or compound. It can be a compound, so it could be more than one element, but they are joined together, and that would be the only compound in that substance if it's pure. And it'll give a relatively flat line at a known temperature, whereas an impure substance will give a sort of variable line and below its standard temperature. The drawing of electronic structures is something that comes up again and again. Remember that you can essentially just follow the periodic table. Lithium is the third element and the first element in the second row. So we would put the 2 electrons in the first row or first shell. Then we're in the second shell, so we would need to add that second shell. And then we would need to add that first electron because we're in the first group. Sodium is also in the first group, but here we've stated that it's the sodium ion, and that will mean that that final shell won't be there, or won't be included, because that electron will have been lost, giving sodium its positive charge. We put the square brackets around to indicate that the electron configuration around sodium has changed, and it's changed by +1. This would be the same for the other ions that are shown here. And this procedure of following the table will work for the other atoms that are shown. When you put them together, you get the structure. So if you're drawing sodium chloride, then it's an ionic structure. And so you're drawing these 2 ions configured. When you're drawing a covalent compound like carbon dioxide, you need to show the overlap, and then you show the electrons that are present that have formed a bond there. When we're talking about the structure of metals, it's important to remember that each of the positive nucleus of the metal atoms that are present will be fixed in place, and it's the electrons that are free to move, allowing those new bonds to form, so that gives the malleable and ductile properties, but also they can be pushed around a circuit, giving it the electrical conductivity, and because the electrons are vibrating free from their nucleus, they increase the speed of conduction in the material, giving it thermal conductivity as well. Remember that the giant covalent structures and their properties are governed by the types of bonds. In diamond, where each carbon is associated with 4 other carbons, the only bond present is covalent bonds, whereas in something like graphite, you'll have the weak intermolecular forces between the 2 layers, but each of those layers will be covalently bonded together. I hope that helps you. If you have any questions, as always, please put them in the comments below. And until then, happy sciencing.